So today we'll study psychometry. So, psychometry is basically जो subject है. So this is the study of moist air. That is the mixture of dry air and water vapor and under different conditions. So whatever ambient condition we have, जो भी air है हम लोग के चारों तरफ. So we say that it is air, but actually it contains various gases and water vapor also. ठीक है. So while studying all the properties and other things, so you consider that this dry air is a mixture of gases, and so all this mixture of gases are considered as a single gas, and it is said to be dry air, and along with that water vapor is taken. So it is a mixture of dry air and water vapor. The molecular mass is taken as that of the dry air is taken as 28.966, and the gas constant value is gas specific constant value is taken as 0.287 kilojoule per kg. Molecular mass of water vapor is taken as 18 point 18 point 18.016, and gas constant is 0.461. So these are the different composition, but however we take this as the dry air and this is water vapor. So the dry air at any particular temperature or pressure has a capacity to hold certain amount of water vapor. Okay, so the maximum amount of water vapor, so that there situation occurs where the water can hold that maximum amount of water vapor. So that condition is called saturated air condition. So so beyond that, your whatever water is evaporated, that becomes in a water liquid droplet form or condensate on cold surfaces. Okay, so this is called saturated air. So this is the degree of saturation. So one term is defined as a measure of how much air content, how much water vapor content is there in the water. So it is the ratio of actual mass of water vapor in a unit mass of dry air to the mass of water vapor in the same mass of dry air when it is saturated at the same temperature. So corresponding to a temperature at a particular temperature value, uh, mm, at a particular temperature value, to in certain condition, what is the amount of mass vapor present, and in saturated condition, whatever the mass of water vapor content. So that ratio is called as degree of saturation, or okay. So another term which is specified to specify the condition of moist air is the humidity or humidity ratio, we say. So it is the mass of water vapor present per kg of dry air. Okay, mass of water vapor present, mass of water vapor present per kg of dry air. So this is called humidity or humidity ratio. So this picture reflects a clear concept of what is moist air. So this is very dry air. This is only dry air. So water is there. So this side your air is there, but 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 the water vapors are not present in there. So it is moist air. Some water vapors are present in the air, and some are getting condensed, and some is evaporating. So this is a maximum condition where your air is saturated. So this is the saturated air, or you can say relative humidity is 100%. So the degree of saturation is specified in terms of percentage. So it is 50%, 60%, or 100%. So 100% relative humidity is called saturated air. Okay. Now, if the temperatures are different, then it may get saturated at 10 grams of water vapor, and it may get uh, saturated at 30 grams, so depending on what is the temperature. So relative humidity is a temperature based So it's dependent on temperature and other conditions. Absolute humidity. So absolute humidity is nothing but the humidity ratio or specific humidity expressed per volume of per unit volume of dry air, or we can say how much grams of water vapor is present, how much gram of water vapor is present per meter cube of the dry air. Okay. So relative humidity is a ratio of actual mass of water vapor in a given volume of moisture to the mass of water vapor in the same volume of saturated air at the same temperature and pressure, briefly written as RH. So dry bulb temperature is the temperature of air recorded by thermometer when it is not affected by the moisture present in the air. So actually कोई भी thermometer या कोई भी temperature measuring device हो वो अगर जो भी air है उसका जो temperature रहता है, so that is your dry bulb temperature. So it is normally denoted as TD or TDB. Okay, so it is not affected by your moisture content. Okay. So when your wet bulb temperature, it is the temperature of air recorded by thermometer when it is bulb is surrounded by a wet cloth or exposed to the dry air. Such a thermometer is called wet bulb thermometer, wet bulb or WBT. It is usually written as WBT. So क्या होता है कि एक तरह का स्लिंग स्लाइकोमीटर रहता है, अगर आप ये देखेंगे. So in this so this is the sling psychrometer. So यहाँ पे दो balls है, ये या ये. So this is dry one. This is surrounded by wet covered belt. So this will measure wet ball thermometer and this will measure dry ball temperature. Okay. Okay. Now this is called sling psychrometer, or we have so this is dry bulb temperature, this is wet bulb temperature. So the difference between the dry bulb temperature and the wet bulb temperature at any point is called wet bulb depression. This wet bulb depression indicates the relative humidity of air. How much difference is there if your air is saturated? Then we'll have very large depression. Okay. And when it is very moist air, little bit moist air, then the depression will be very less. Okay. So the dew point temperature. So if the temperature recorded by a thermometer when the moisture is present, it begins to condense. Okay. In other words, the dew point temperature is the saturation temperature corresponds to the partial pressure of water vapor. So according to Dalton's law of partial pressure, here the gas has different components. So corresponding to a gas, it will have this pressure. So water vapor, the contribution by water vapor to the pressure will be very less. So the saturation temperature will be the uh, so corresponding to that pressure. So you have to we will check whether that vapor is in saturated condition or superheated condition. So corresponding to that pressure, your saturation temperature will be very low. Normally, your water vapor stays in the mixture as superheated vapor. Okay. So your this is your water vapor pressure. So corresponding to that line, so this is the TH diagram line. This is the constant pressure line, and this point will be the dew point temperature or the saturation temperature corresponding to the saturation temperature corresponding to this pressure is your called dew point temperature. Now your saturation temperature, saturation temperature, or what we say, is the same temperature at which your water vapor is present. Your this or the pressure at which your saturation temperature is equal to the dry bulb temperature. This will be the what, PS, or saturation pressure. Okay. Now this line is the saturated air line. Okay. Now at the same temperature, if you go on adding, at the same temperature, if we go on adding constant pressure lines, or we can say we go on adding water vapor, then this line goes on moving like this. So at this point here, this point, it is here PS, or where it becomes saturated. Okay. So this is here saturation pressure line, or this condition is saturated air. That is it in here. When the partial pressure of water vapor PV is equal to the saturation pressure, the water vapor is in dry condition, or the air will be saturated air. Thank you. This much for today. अभी पहले देखते हैं other properties क्या है, enthalpy, और will derive the relation between different quantities. Thank you.